Hello, this is Ruchika, a student at Brindavan College of Engineering in the Department of Electronics and Communication. As an intern at EMERTXE, I'm going to explain about the project Microwave Oven Stimulation. So, taking a look into the table of contents, these are the table of content topics. So, starting with topics learned during the internship, project requirements, introduction to the microwave oven, microcontroller, embedded system, project peripheral, CLCD, microcontroller, tactile switch, matrix keypad, interrupts, project implementation. So, the first topics learned during the internship. As an as an intern at EMERTXE, we learned about the introduction to embedded C programming, which is basically how a C programming can be used in the embedded systems. Arrays, pointers, function strings, preprocessors, storage classes, conditional loops and operation, introduction to embedded systems, microcontrollers, Pixim Lab, MP Lab XDE, XC8 compiler, introduction to various peripherals. Next, project requirements. For the project, we needed MP Lab XIDE, XC8 compiler, Pixim Lab of version PIC16 F877A, 16 cross 4 CLCD, MKB, timer 2, tactile switch. Next, the introduction to the microwave oven. Basically, a microwave ovens are a convenient means to heat food and are generally safe when used correctly. Microwave ovens heat food using microwaves, a form of electromagnetic radiation similar to radio waves. So, there are several modes in which a microwave oven operates in. In this project, we specially focus on the four modes. Those are micro mode, grill mode, convection mode, and start mode. So the first, micro mode. This mode is used when you want to cook in a traditional way. In this in this process, the frequency generator inside the oven works and generates high frequency waves which cooks the food from inside and out. It generally requires a maximum power of 900 watt. Next, moving on to the grill mode. It's simply used for grilling. The user can set any time accordingly here. It is similar to micro mode but is more used for cooking breads, meat and other items. Next, moving on to the convection mode. It is used for baking. In this mode, the user can set the oven to preheat for 3 minutes for a particular temperature. After preheating is done, the user can set a timer according to the requirement. Moving on to the microcontroller. So basically, microcontrollers is a small computer on a single integrated circuit that is designed to control a specific tasks within electronic system. It combines the function of CPU, memory, and input-output interfaces, all on a single chip. Microwave microcontrollers are programmable, which means that they can be customized to perform specific tasks. Moving on to the embedded systems. So basically, an embedded system is a microprocessor based computer hardware system with software that is designed to perform a dedicated function. Then, now a microcontroller about the applications of embedded system. Applications in my embedded system ranges from digital watches and microwaves to hybrid vehicles and avionics. This chart demonstrates the different applications of embedded system. Here is the project peripheral. This is a PIC16 F877A architecture. Moving on to the CLCD. CLCD stands for Character Liquid Crystal Display. In Pixim Lab, there are two types of display, 16 cross 2 display and 16 cross 4 display. It has two types of modes for communication, 4-bit mode and 8-bit mode. Moving on to the tactile switch. It is a switch whose operation is perceptible by touch. This switch used to select the mode of operation and to enter the temperature and time in our project. This switch can produce a bouncing effect when a switch is pressed. Here is a matrix keypad. This is a 4x4 keypad and has built-in push button contacts connected to the rows and column lines. So a microcontroller can scan these buttons for a button pressed state. These are the lines for the button press stage which a microcontroller can scan. Next are the interrupts. An interrupt is a communication process set up in a microcontroller in which a internal or external device requests the MPU or MCU to stop the processing. Then this MPU or MCU acknowledges the request and attends to request. It goes back to the processing where it got interrupted. An ISR is a software routine that hardware invokes in response to an interrupt. ISR stands for Interrupt Service Routine. Next, moving on to the project demonstration, here we have selected PiximLab of version PIX16 F877A. This is basically a microcontroller which is of 8 bits. It consists of a clock frequency, a heater, and a cooler. And here is the heater, which is an inbuilt heater and which is inbuilt peripheral in 16F877A. Now to load the file, we have to go to File and Load Hex. It shows the hex file and we have to load the hex file. Once it's done, powering on, and now here we can see the 4 modes: micro, grill, convection, start. Pressing 1, we select power mode. It is showing 900 watts, which is maximum power supplied to it. It is showing 900 watts, and now this timer displays minutes and seconds. This minutes and seconds can max up to 59 minutes and 59 seconds. And also by giving star and enter, we can clear and enter the time, like confirm and enter the time. Now for example, we give the time of 10 seconds. So 1 0. So we have given the timer of 10 seconds. Now if we press the star, it clears the time. Again pressing 1 0 of time 10 seconds, we press hash, which is enter the time. As we enter the time, the fan starts to rotate and the time starts to decrease. Here we can start, pause and abort as required using 4, 5 and 6. Now if we press 5, it pauses, the fan stops rotating. Now if we press 4, it resumes again, and once the time is up, it shows cooking time up. Since if the timer goes to 00, it shows cooking time up. Now coming to second mode, that is grill mode. Same, the timer shows minutes and seconds. It can max up to 59 minutes and 59 seconds. We'll give example of 6 seconds. 6 seconds and enter. Now the fan starts to rotate again. We can pause it, resume it. Now once this timer is up, we can see the same cooking time up display. Once this operation is done, it shows it. Now we have completed the grill operation mode. Now we can move on to the convection mode. Pressing 3. Here we have to enter the temperature. If we enter maximum temperature of 500, so we get here an error because it's a maximum temperature, so it says invalid temperature. Now we have to enter the temperature, which should be under 250 degrees Celsius. Now we enter the 100 degree. When we enter it, it starts preheating and it displays the time remaining. Now to fasten this time remaining, we can move to the clock cycle and using the clock frequency, and we can make the clock time go faster. It reduces the time. So now we can see the time is being reduced faster than before. So this convection mode is basically a preheating mode. by which if when we enter the temperature we can see the oven being heated as per our requirement and the temperature we need. After the convection mode ends, we can just load the hex file again. It has ended. Now what we do is we press the star and clear the time and then go to the clock, select 30 seconds, then go to file, hex, and select it again and open it. Here we can see the 4 modes again. Now if you press 4, it goes into start with the timer of 30 seconds which we predefined it. Pressing 5, it stops, pauses. The rotation has been paused and the time reduces. Pressing the 4, it resumes again. We can change it according to our usage. Now we give 6 and it can stop. Hence, this finalizes our project and all 4 modes of operation in the microwave oven. Thank you.